Hey guys, Mr. T here, just doing a quick video on the idea of analyzing residual plots. So we've gone with a previous video showing you how to draw up a residual plot for a set of data. It is important to take this extra step of analyzing the residual plot itself and its shape for a set of data because we've already said that r and r squared only measure how close the data points are to a straight line that the calculator has made to fit that data. The problem with that is r and r squared don't recognize any patterns in the data. All it talks about is the closeness, how strong that correlation is. It doesn't care whether the dots in the data lie in a particular way that indicates a line isn't the best method of describing the model of the data. So, for example, we have this. If you looked at the following scatter plot and associated residual plot, you've got this. And this isn't to scale, I don't obviously have any numbers here, but let's pretend that you had a scatter plot and your data points were these blue dots here. And if you were to fit a least squares regression line to it, it would probably develop something like that. Sort of through the middle, you've got 2 data points above the line, 2 data points below the line, and 2 on the line. But you can see that there's sort of a delineation here. You've got the 2 above the line on the outside, 2 on the lines just in from that, and then the 2 below the line are right next to each other in the middle. If you were to draw a residual plot of this, okay, you would see this. You would see clearly that there is a pattern to the layout of the residuals. You can see that this is above the x-axis because this point is a positive residual. It lays above the line of best fit. This is on the x-axis because this point lies directly on the line of best fit. These two are below. These two are below. On the line, and above the line, above the line. But the residual plot, the way it works, makes this more evident than it would be on the straight scatter plot with a line of best fit drawn through it. So that leads us to the idea that the residual plot reveals patterns in the data that you don't see with r and r squared. So in general, if you find a residual plot has points scattered randomly about the x-axis, then you're fine to suggest a linear model is appropriate. So if you saw something like this is a residual plot of a set of data. I don't have the data, I'm just making it up. But if you had a residual plot that appeared like so, there's no particular pattern to it, it looks randomly scattered. And the residuals aren't too huge. Not extremely large. Residuals in the positive and negative direction. Therefore, linear model appropriate. So you're able to conclude from this second checking method of a residual plot, if the residual points are scattered randomly about the x-axis, a linear model would be appropriate. Now, contrasting that with a residual plot where you find that the residuals lay in such a way. It doesn't have to be this particular way, I'm just giving this as an example, but you might have a very clear curving pathway to the residuals. Not random. Pattern apparent. You can see that you could draw like a curved line through those dots. You would have to come to the conclusion that a linear model not appropriate. So we're mostly learning about linear models here, and we might not be able to fit an actual model to this data, but what you can conclude as from this residual plot is a line is not the best way to model this particular data. If you see the residual plot looks like that, or has a particular pattern to it, all right? The only other thing to think about is if you find a residual plot has randomly scattered points like this, but the residuals are really big compared to your data points, so like you had residuals of like 15 and your data was like 10 or even less than that, then that would also indicate a linear model is not appropriate, and it might even go to the extent that those residuals are so big that it's not even a linear model. Those points are just random scattered points. There's no relationship whatsoever. Okay? So hopefully that helps you out with the idea of analyzing residual plots, and I'll see you in the next video.